Hello everyone and welcome. I'm Professor Diwa. In this video, I'll be going over radical equations and problem solving. Our objectives are to solve equations that contain radical expressions, use the Pythagorean theorem to model problems. Alright, so let's get started. First, we have the principle of powers. It states here that if a equals b, then a to the nth power equals b to the nth power for any exponent n. In the next set of examples, we're going to use the principle of powers to help us solve radical equations. In example number 1, solve. For part A, we have the square root of 3x plus 10 plus 2 equals 4. To solve a radical equation, we need to isolate the radical on one side of the equation. In this case, we need to get rid of the plus 2 by subtracting 2 from both sides of the equation. On the left-hand side, the plus 2 minus 2 will cancel out, and then we bring down the square root of 3x plus 10. On the right-hand side, 4 minus 2 is 2. So the result is the square root of 3x plus 10 equals 2. The next step here is getting rid of the radical. To do this, we're going to use the principle of powers by taking the square of both sides of the equation. Starting with the left-hand side, we take the square of the square root of 3x plus 10. This will just be 3x plus 10. On the right-hand side, we have 2 squared, which is 4. The result is 3x plus 10 equals 4. Next, we need to get rid of the plus 10 by subtracting 10 from both sides of the equation. On the left-hand side, the plus 10 minus 10 will cancel out, and we bring down the 3x. On the right-hand side, we have 4 minus 10, which is negative 6. So the result is 3x equals negative 6. Next, we get rid of the 3 by dividing both sides by 3. We get 3x divided by 3 equals negative 6 divided by 3. Simplifying the left-hand side, 3x divided by 3 is x. On the right-hand side, negative 6 divided by 3 is negative 2. So the result is x equals negative 2. The next step here is verifying that negative 2 is a solution to our equation. So we take negative 2 and plug it into the original equation for x. We get the square root of 3 times negative 2 plus 10 plus 2 equals 4. Next, we simplify. 3 times negative 2 is negative 6, and then we bring down all the other terms. So we have the square root of negative 6 plus 10 plus 2 equals 4. Next, we add together negative 6 and 10, which is 4, and then we bring down all the other terms. We get the square root of 4 plus 2 equals 4. Next, we take the square root of 4, which is 2, so we have 2 plus 2 equals 4. Adding 2 plus 2 together, we get 4 equals 4. So this is a true equation, and this verifies that negative 2 is a solution to our equation. Next, we write our final answer in set notation. So I have a set of curly brackets and negative 2 on the inside. For part B, we have the cube root of 3x minus 12 plus 4 equals 1. Again, we need to isolate the radical on one side of the equation. So I'm going to get rid of the positive 4 by subtracting 4 from both sides of the equation. On the left-hand side, positive 4 and negative 4 cancels out, and we bring down the cube root of 3x minus 12. On the right-hand side, 1 minus 4 is negative 3. So we have the cube root 3x minus 12 equals negative 3. Next, we get rid of the cube root by using the principle of powers. We take the cube of both sides of the equation. On the left-hand side, taking the cube of the cube root of 3x minus 12 gets rid of the radical, and we have 3x minus 12. On the right-hand side, negative 3 cubed is negative 27. So the result is 3x minus 12 equals negative 27. The next step here is getting rid of the minus 12, so I added 12 to both sides of the equation. On the left-hand side, negative 12 plus 12 cancels out, and we bring down the 3x. On the right-hand side, negative 27 plus 12 is negative 15. So the result is 3x equals negative 15. Next, we get rid of the 3 by dividing both sides by 3. We have 3x divided by 3 equals negative 15 divided by 3. Simplifying the left-hand side, 3x divided by 3 is x. On the right-hand side, negative 15 divided by 3 is negative 5. so the result is x equals negative 5. Next, we verify that negative 5 is a solution to the equation. We just take negative 5 and plug it in for x in the original equation. We have the cube root of 3 times negative 5 minus 12 plus 4 equals 1. Next, we simplify. 3 times negative 5 is negative 15, and we bring down all the other terms. So we have the cube root of negative 15 minus 12 plus 4 equals 1. Next, we have negative 15 minus 12, which is negative 27. So we have the cube root of negative 27 plus 4 equals 1. Taking the cube root of negative 27, we get negative 3, and then we bring down the plus 4 equals 1. Next, we add negative 3 and 4, which is 1, and we have 1 equals 1. So the equation is true, and this means that negative 5 is a solution to the equation. So we write our final answer in set notation. So I have a set of curly brackets with negative 5 on the inside. Next, we have a practice problem. Solve. For part A, we have the square root of 5x minus 1 plus 7 equals 5. For part B, we have the cube root of 3x plus 1 minus 4 equals negative 6. Alright, so go ahead and pause the video, take your time working out these problems, make sure you verify your answers after you finish, and then check back with the video to make sure you got everything correct. Alright, so let's go over the practice problems. For part A, we need to isolate the radical by subtracting 7 from both sides of the equation. The result after doing the subtraction is the square root of 5x minus 1 equals negative 2. The next step here is using the principle of powers and taking the square of both sides of the equation. This gets rid of the square root, and the result is 5x minus 1 equals 4. Next, we solve for x by getting rid of the negative 1. We just add 1 to both sides of the equation. The result is 5x equals 5. Next, we divide both sides by 5. We have 5x divided by 5 equals 5 divided by 5. After simplifying the equation, the result is x equals 1. Next, we verify that our answer is a solution to the equation. We take 1 and substitute it in for x in the original equation. We get the square root of 5 times 1 minus 1 plus 7 equals 5. Next, we simplify the terms under the radical. We have 5 times 1 is 5, and then we bring down all the other terms. We have the square root of 5 minus 1 plus 7 equals 5. Next, we have 5 minus 1, which is 4, so we have the square root of 4 plus 7 equals 5. Taking the square root of 4, we get 2, and then we bring down the plus 7 equals 5. Next, we add together 2 and 7, which is 9, and you can see here that 9 is not equal to 5. So the value of 1 is not a solution to the equation. To indicate that we have no solution, I use the circle with the diagonal line going through it. For part B, again we need to isolate the radical on one side of the equation, so I added 4 to both sides of the equation. The result is the cube root of 3x plus 1 equals negative 2. Next, we get rid of the radical by taking the cube of both sides of the equation. The result is 3x plus 1 equals negative 8. Next, we solve for x by getting rid of the positive 1. We just subtract 1 from both sides of the equation. The result is 3x equals negative 9. Next, we get rid of the 3 by dividing both sides by 3. We have 3x divided by 3 equals negative 9 divided by 3. After simplifying the equation, we get the result is x equals negative 3. Next, we verify that negative 3 is a solution to the original equation. We substitute negative 3 into the original equation for x. We get the cube root of 3 times negative 3 plus 1 minus 4 equals negative 6. Next, we simplify. 3 times negative 3 is negative 9, and then we bring down all the other terms. So I have the cube root of negative 9 plus 1, negative 4 equals negative 6. Next, we have negative 9 plus 1 is negative 8, so I have the cube root of negative 8 minus 4 equals negative 6. Taking the cube root of negative 8, we get negative 2, and then we bring down all the other terms. So I have negative 2 minus 4 equals negative 6. Next, we have negative 2 minus 4 is negative 6, and we have negative 6 equals negative 6. This is a true equation, which means that negative 3 is a solution to our equation. So we write our final answer with a set of curly brackets and negative 3 on the inside. For example number 2, solve. We have the square root of x plus 5 equals x minus 1. Since the radical is isolated on the left-hand side, we could go ahead and get rid of the radical by squaring both sides of the equation. So I have parentheses, square root of x plus 5, and a square on the parentheses, equals parentheses x minus 1 and a square on the parentheses. On the left-hand side, the square will get rid of the radical, so the result is x plus 5. On the right-hand side, parentheses x minus 1 squared is a perfect square, so we could just multiply it out using the perfect square formula. This will give us x squared minus 2x plus 1. Next, we need to set one side of the equation equal to 0, so I'm going to subtract x from both sides and subtract 5 from both sides of the equation. The result is 0 equals x squared minus 3x minus 4. Next, we factor the trinomial x squared minus 3x minus 4. The result is 0 equals parentheses x minus 4 times parentheses x plus 1. Next, we use the zero factor property. We get x minus 4 equals 0 and x plus 1 equals 0. Solving the first equation for x, we add 4 to both sides of the equation. The result is x equals 4. Solving the second equation for x, we subtract 1 from both sides of the equation. The result is x equals negative 1. Next, we verify our answers. We take 4 and plug it into the original equation. We get the square root of 4 plus 5 equals 4 minus 1. After simplifying, we get the square root of 9 equals 3. Square root of 9 is 3, and 3 equals 3. So this means that 4 is a solution to the equation. Next, we check x equals negative 1. Plugging in negative 1 into the original equation, we get the square root of negative 1 plus 5 equals negative 1 minus 1. After simplifying the equation, we get the square root of 4 equals negative 2. Taking the square root of 4, we get 2 equals negative 2, which is false, so negative 1 is not a solution. Our final answer we write in set notation, so I have a set of curly brackets and 4 on the inside. Next, we have a practice problem. Solve. We have 3 plus the square root, 5 minus x, equals x. Alright, so go ahead and pause the video, work out this problem, and then check back with the video after you finish. Alright, so let's go over the practice problem. First, we need to isolate the radical on one side of the equation, so I started off by subtracting 3 from both sides. The result is the square root of 5 minus x equals x minus 3. Next, we get rid of the square root by taking the square of both sides of the equation. The result after taking the square of both sides is 5 minus x equals x squared minus 6x plus 9. Next, we set the equation equal to 0 by subtracting 5 from both sides and subtracting x from both sides of the equation. We get 0 equals x squared minus 5x plus 4. Next, we factor. We get 0 equals parentheses x minus 4 times parentheses x minus 1. Next, we use the zero factor property. We get x minus 4 equals 0, x minus 1 equals 0. Solving the first equation for x, we add 4 to both sides. The result is x equals 4. Solving the second equation for x, we add 1 to both sides. The result is x equals 1. Next, we verify our answers. Starting with x equals 4, we plug it into the original equation. We get 3 plus the square root of 5 minus 4 equals 4. Next, we simplify. 5 minus 4 is 1, so we have 3 plus the square root of 1 equals 4. Taking the square root of 1, we get 1, so I have 3 plus 1 equals 4. Next, we add 3 plus 1, which is 4. So we have 4 equals 4, which is a true equation. so 4 is a solution to the equation. Next, we check x equals 1. We have 3 plus the square root 5 minus 1 equals 1. Next, we simplify. 5 minus 1 is 4, so we have 3 plus the square root of 4 equals 1. Next, we take the square root of 4, which is 2, so we have 3 plus 2 equals 1. Next, we add 3 and 2 together to get 5, so we have 5 equals 1, which is false. So x equals 1 is not a solution. Our only solution is 4, so we write our final answer with a set of curly brackets and 4 on the inside. For example number 3, solve. We have the square root of 3x plus 6 minus square root of x plus 6 equals 2. In this equation, we have two radicals. We still need to isolate one of them on one side of the equation. So first, I'm going to add square root of x plus 6 to both sides of the equation. The result is the square root of 3x plus 6 equals 2 plus the square root of x plus 6. Next, we could get rid of the radical on the left-hand side by taking the square of both sides of the equation. Taking the square of the square root of 3x plus 6 will cancel out the square root and give us 3x plus 6. On the right-hand side, we have a perfect square, so we can multiply this out using the perfect square formula. We just square the first term, 2 squared is 4. Square the second term, the square root of x plus 6 squared will cancel out the square root and give us x plus 6. Next, we multiply the two terms together. 2 times the square root of x plus 6 is 2 root x plus 6, and then we double it. So we have 4 root x plus 6. So the result is 3x plus 6 equals 4 plus 4 times the square root x plus 6 plus x plus 6. Next, we combine like terms. We could add together the 4 and 6 to get 10, and then bring down the other terms. So we have 3x plus 6 equals 10 plus 4 times the square root of x plus 6 plus x. Next, we need to isolate the square root on one side of the equation, so I'm going to subtract x from both sides and subtract 10 from both sides. The result is 2x minus 4 equals 4 times the square root of x plus 6. Next, we get rid of the square root by taking the square of both sides of the equation. On the left-hand side, we have a perfect square, so we can multiply this out using the perfect square formula. 2x squared is 4x squared. 4 squared is 16. Multiplying 2x and negative 4 together, we get negative 8x. Doubling it, we get negative 16x. Squaring the right-hand side, we get 16 times the parentheses x plus 6. So the result is 4x squared minus 16x plus 16 equals 16 times the parentheses x plus 6. Next, we distribute the 16 inside the parentheses to the x plus 6. We get 16x plus 96, and then we bring down all the other terms. So we have 4x squared minus 16x plus 16 equals 16x plus 96. From here, we need to set the equation equal to 0, so we subtract 16x from both sides and subtract 96 from both sides. The result is 4x squared minus 32x minus 80 equals 0. Next, we can factor out a common factor of 4 from the 4x squared minus 32x minus 80. The result is 4 times the parentheses x squared minus 8x minus 20 equals 0. Next, we can factor the x squared minus 8x minus 20. The result is 4 times the parentheses x minus 10 times the parentheses x plus 2 equals 0. From here, we use the zero factor property. We get x minus 10 equals 0 and x plus 2 equals 0. Solving the first equation for x, we just add 10 to both sides of the equation. The result is x equals 10. Next, we solve the second equation for x. We subtract 2 from both sides of the equation. The result is x equals negative 2. After verifying the solutions, x equals negative 2 is not going to be a solution. The only solution we have is x equals 10, so we write our final answer in set notation with a set of curly brackets and 10 on the inside. Next, we have a practice problem, solve. we have the square root of 2x plus 1 minus the square root of x plus 4 equals 1. Alright, so go ahead and pause the video, take your time working out this problem, and then check back with the video to see the solutions. Okay, so let's go over the solutions. First, we need to isolate one of the radicals on one side of the equation, so I'm going to add the square root of x plus 4 to both sides of the equation. The result is the square root 2x plus 1 equals 1 plus the square root of x plus 4. Next, we get rid of the radical by squaring both sides of the equation. On the left-hand side, we take the square of the square root of 2x plus 1. This will cancel out the square root and give us 2x plus 1. On the right-hand side, we have a perfect square, so we multiply this out using the perfect square formula. Squaring the first term, we have 1 squared is 1. Squaring the second term, the square root of x plus 4 squared is just x plus 4. And then we multiply the two terms together. 1 times the square root of x plus 4 is the square root of x plus 4. We double that, and we get 2 times the square root of x plus 4. So the result is 2x plus 1 equals 1 plus 2 times the square root x plus 4 plus x plus 4. Next, we could combine like terms. We could add together the 1 plus 4 on the right-hand side. This will give us 5. And then we could bring down the rest of the terms. So we have 2x plus 1 equals 5 plus 2 times the square root of x plus 4 plus x. Next, we need to isolate the square root on one side. So I'm going to subtract x from both sides and subtract 5 from both sides. The result is x minus 4 equals 2 times the square root of x plus 4. Next, we get rid of the radical by squaring both sides of the equation. We can multiply the left-hand side out as a perfect square. X squared is x squared. 4 squared is 16. X times negative 4 is negative 4x. Double that, we get negative 8x. Squaring the right-hand side, 2 squared is 4. And squaring the square root of x plus 4 will just give us x plus 4. So the result is x squared minus 8x plus 16 equals 4 times the parentheses x plus 4. Next, we distribute the 4 inside the parentheses to the x plus 4. We get 4x plus 16, and then we bring down the rest of the terms. So we have x squared minus 8x plus 16 equals 4x plus 16. Next, we set one side of the equation equal to 0. We just subtract 4x from both sides and subtract 16 from both sides. The result is x squared minus 12x equals 0. Next, we could factor out a common factor of x from the x squared and the minus 12. The result is x times the parentheses, x minus 12 equals 0. From here, we use the zero factor property, so we have x equals 0 and x minus 12 equals 0. Next, we solve the second equation for x by adding 12 to both sides of the equation. The result is x equals 12. After verifying the solutions, x equals 0 is not a solution. The only solution we have is x equals 12. So our final answer, written in set notation, is curly bracket 12 and then a close curly bracket. Next, we have the Pythagorean Theorem. It states here that if a and b are the lengths of the legs of a right triangle and c is the length of the hypotenuse, then a squared plus b squared is equal to c squared. In the diagram below, we have a right triangle where we have a on the left side, b on the bottom, and c is the longest side opposite of the right angle. In the next example, I'm going to show you how we can apply the Pythagorean theorem. In example number 4, the current route of the Great Court Run at Trinity College runs along the perimeter of a grassy shape that resembles a rectangle. If the dimensions of the grassy rectangle are approximately 80 meters by 100 meters, how far would a student travel by walking across the grass from corner to corner? Give an exact answer and a 1 decimal place approximation. In the diagram on the right side, we have a rectangle which depicts the current route of the Great Court Run. If a student were to walk across from one corner of the rectangle to the other, this would create a right triangle. So we could use Pythagorean theorem to find the distance across from one corner to the other. On the bottom of the right triangle, we have 100 meters. On the right side of the right triangle, we have 80 meters. The hypotenuse will represent the distance going across from one corner to the other. So this will be the value c. Next, we just substitute our values of 100 in for a and 80 for b into Pythagorean's theorem. So we get 100 squared plus 80 squared equals c squared. Next, we simplify. 100 squared is 10,000, 80 squared is 6,400, so we have 10,000 plus 6,400 equals c squared. Next, we add 10,000 and 6,400, we get 16,400. So we have 16,400 equals c squared. Next, we could solve for c by taking the square root of both sides of the equation. So we have the square root of 16,400 equals the square root of c squared. The result is c equals the square root of 16,400. Next, we need to break down the square root of 16,400 so that we can get an exact answer. So we need to break apart 16,400 into a product of two numbers, where one number is the largest perfect square we can get from 16,400. So I rewrote this as the square root of 400 times the square root of 41. Next, we could take the square root of 400, which is 20, so we get c is equal to 20 times the square root of 41. Next, the problem also wants a 1 decimal approximation, so we just use a calculator to find the value of 20 times the square root of 41, and then round that value to 1 decimal place. I got the value that c is approximately equal to 128.1. Now we could write our final answer. A student would travel 20 root 41 meters, or approximately 128.1 meters, by walking across the grass. Alright, this is the end of our video. Thank you very much for watching. I'm Professor Diwa, and I'll see you in the next one.